Hello guys! So, for those of you that may have forgotten how to do scientific notation or missed out when we learned about scientific notation, we're going to work a few examples, talk about some of the common mistakes that people make with it, and hopefully get you guys caught up and back on track. I think there's about 5 or 6 scientific notation questions on your test. First things first, the main reason we're going to use scientific notation is because really big numbers and really small numbers are, number one, super annoying to write. Number two, have a lot of zeros in them and can leave room for a lot of error. And number three, in science, we want to maximize efficiency and accuracy too. So this kind of makes our lives a little bit easier to write these really large or really small numbers. Large number here. We'll put some commas in to make it a little bit easier. We're going to obey the number one rule of scientific notation, and that rule is you want one number and one number only on the left-hand side of your decimal. That is not a zero, okay? Your goal is to move your decimal until there is one number and one number only that's not zero on the left of it, okay? That's the goal. Don't overthink it. Don't make it overcomplicated. One non-zero number to the left. Now, in this, all the other numbers that aren't zero, they're important. You're going to have to keep them whenever you put it into scientific notation. And it sounds a little crazy and confusing. I'm like, what is she going on about? It'll make more sense when you practice it and do some practice problems. And I'll give you a few and you can pause the video and try them out. So with this, we have a large positive number that is a whole number, okay? And these types of numbers have an imaginary decimal at the end of them that nobody ever writes, just because there's really no point in putting it there. We're again going to move our decimal until there is only one number on the left-hand side that's not a zero. So we bounce it a few times. Well, there's still a whole lot of numbers to the left of it, so we have to keep going. Now there's only 2 numbers to the left of it. We're almost there. And right here, that is where we're going to want our decimal for this. Now, scientific notation has a very specific way that you write it. The formula for scientific notation is always going to be something point something times 10 to a power. Every single time. You're going to have something point something times 10 to the something, and I'll help you fill in the blanks as we go. Our decimal is going to be 8. That's why there's a little tiny blank here, because there's room for only one number, because one number goes to the left of it. And all these other numbers that aren't zero have to be included in it. And even though that is a zero, because it's trapped between 2 non-zero numbers, it's also important enough to be included in our decimal. So we have 8.675309 times 10. I told you it's going to be to a power. So the way that you get your exponent up here, all you do is count the number of decimal hops. And I'm going to change colors so there's a little bit of contrast. We'll see if a nice dark purple will show up. So we hopped it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hops. 10 hops to our decimal. And that 10 is your exponent. It's that simple. That's how you put large numbers in scientific notation. You just take the decimal, you bounce it to there's literally one non-zero number to the left of it, and you just rewrite your decimal times 10 to the number of hops that you did. So I'll give you a practice problem, and we'll see if you end up getting the right answer. Okay, so here's your number. Give it a shot. Pause the video. See if you can put this into scientific notation, and I'll give you the answer. Let's check and see if you got that right. So again, our decimal is here at the end because this is a large whole number. And we would move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times. 14 times. This is one of those things where unfortunately you kind of have to write sort of neat. Otherwise, you'll accidentally skip 2 numbers at one time or do something that'll put your count off. So make sure that you are hopping each individual number. So our decimal then is going to be 9.90213 times 10 to the 14th power. Hopefully you got that right. If you didn't, you probably need to go to Google Classroom and leave me a comment and let me know what threw you off and where you messed up in your answer, and I'll do my best to get back to you this weekend. The next example we're going to look at is putting a really, really, really little tiny number, like one that's way, way, way smaller than 0, into scientific notation. I have a little itty bitty tiny decimal number here. Remember your goal. You want one number and one number only on the left-hand side of the decimal that is not 0. Once you've achieved that goal, that's where you stop. These are the ones that tend to throw people off the most because they want to hop their decimal a few too many times. So here's how you would make it work. Another error that I've seen kids do is they've put an imaginary decimal here. Don't do that. That is wrong. Okay? You were given a decimal. So this is your starting point. You're going to start at this 0 and move this way until you have one number that's not 0 to the left. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is where you're going to want to stop and put your new decimal. The reason you're going to want to stop here is I have achieved my goal of one number on the left-hand side of the decimal that's not 0. A lot of people want to keep hopping until there's one number dangling on the right. Don't do that. That breaks the basic rules of scientific notation. So here's how you would now write this, since this is a small number that's less than 0 in scientific notation. So 4.81 from right here, 4.81. You still have your something point something times 10, and our exponent, we moved it 11 times. But because this is a number that is less than 1, your exponent's going to be negative. That negative is very, very, very important. This is another thing a lot of people end up leaving out whenever they deal with these tiny numbers. That negative and positive, that differentiates between whether you're making a huge number or a very, very small number. Okay? I kind of think about like my bank account. I'd rather see my bank account be a big, huge number, like a regular, normal, big exponent, than a little, itty bitty, tiny number like this. And I associate the little tiny numbers with a negative exponent. So let's do a practice problem and see how you do. Pause the video, give it a shot, see if you can put this into scientific notation, and once again, I will give you the answer and how I work through it. You've got your decimal right here as your starting point. Remember, don't make an imaginary one. Don't count an extra hop for this one. This is your starting decimal. So start there. So we're going to hop 1, 2, 3, 4, 5, 6 times for our brand new decimal spot, because again, we have achieved that goal of one number that is not 0 to the left. As soon as you achieve that goal, stop moving your decimal point. Your new decimal is 2.513 times 10 to the 1, 2, 3, 4, 5, 6 to the negative 6th power. And again, that negative is super, super, super important. Please don't forget it. That really will make the difference between whether your answer is right or wrong. These are your examples of how to put really, really tiny numbers into scientific notation. Again, just like before, if you don't understand, if something threw you off, please let me know. There is a worksheet also on Google Classroom that we did. I have a hard copy I can give you next week if you didn't get one or don't have a printer, but there are several problems like this that you will need to put into scientific notation. So keep that rule in mind. one non-zero number to the left. Now let's show you how to take numbers out of scientific notation, which in my opinion is a lot easier. So to take numbers out of scientific notation, we're going to start with a big number. And the way, again, I'm going to know it's a big number is I'm going to zero in and look at this exponent. This exponent's going to tell me if it's positive, I'm going to make a big number. If it's negative, I'm going to make a little itty bitty tiny number. So here's where you kind of have to ask yourself, which way do I move the decimal to make it big and which way do I move it to make it small? Well, let's just make a little decimal and practice moving it. Here's our number. I just made a very movable decimal. If I move the decimal to the left, I have not made a larger number. In fact, the number now is smaller than 0. I would have 0.1042. So in order to make it a bigger number, you're going to have to end up moving it to the right. If I were to move the decimal one place to the right, I'd go from 1 point something to 10 point something. 10's a much bigger number. So when you're making a positive exponent and taking it out of scientific notation, you're going to move your decimal to the right. And the number of times you're going to move it to the right is the exponent. Do not make the common mistake. Most people think, oh, there's an exponent of 11. I'm going to slap 11 zeros on the end of it. That's the answer. Done deal. That's the number of times you move the decimal. Okay? Don't forget that. That's really, really, really important. So if I were working this out, I would rewrite this. I'll make the decimal a little bit easier to see. And here's how I would end up working it out. I would move 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's where my new decimal is, and I know that's where the number ends. Now, all these hops that I did that aren't filled in, all you're going to do is throw a 0 in there. So again, we started here and only moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So this is going to tell you whether you're making a big number or a small number, and whether you're moving your decimal to the right or to the left. And we'll throw some commas in here to make it a little prettier and nicer to look at. And as you can see here, we had 3, 6, 9 zeros end up on the end of this, not 11. Okay, that's why the 11, the exponent, is not the number of zeros you put, it's the number of times you bounce your decimal. So we'll do an example problem and see how you do. Here's your example. Do your best to take this one out of scientific notation, and let's see what you get. So again, here's how I would work through this as a problem. We take our decimal, we would go 1, 2, 3, 4, 5. And the little extra hops, we'll fill in with zeros. And there's your answer. And put a little comma in there. Not a pretty comma, but a comma. So not as big of a number as the last one that we used, but that's how you're going to take it out of scientific notation. Again, if it's not clicking or you need more practice, go find that worksheet on Google Classroom or put a comment, send me a question. Now we're going to look at the last examples and last way that we deal with scientific notation in my class, which is going to be to take a negative exponent number, so a little itty bitty tiny number, out of scientific notation. So in the previous examples, if you move the decimal to the right in order to make it a big number, you're going to move it to the left in order to make it a little itty bitty tiny number. So let's actually move this one over some. That way I can bounce my decimal that direction. So we've got our 3.97 here. I'll remove the decimal 8 times. 1, 2, 3, 4, 5, 6, 7, 8. All right, there's our new decimal location. And we're going to fill in our hops with some zeros, some very non-symmetrical zeros. And there's your answer. It's not pretty, but there's your answer. And this negative number. Again, pay attention to your exponents. They are so very important. If you've got a negative number like this, it's going to tell you you're making a little itsy bitsy teeny tiny number. So let's give you your practice problem and finish this up. Okay, here's your practice problem. 2.4 times 10 to the negative 3. Take that out of scientific notation and see how you do. We have 2.4. We're going to bounce our decimal 3 times. It is negative, so we're going to bounce it to the left. And we'll go 1, 2, 3. And as always, we fill in our empty hops here with some zeros. And there you have it. And that's your answer. Hopefully this helped. I hate that you guys were quarantined and missed out. But again, I'm always here for you. Put your questions and stuff in Google Classroom. Get that worksheet done, and you should be all caught up and good to go. There are 3 PowerPoint slides in your notes that cover scientific notation and give a lot more examples and are really, really, really super detailed. So I would recommend, if you read those and they blew your mind and you didn't understand them, this video should help a lot more. Scientific notation is one of those things, the more you practice and the more you try, the more it starts to click and make sense. So use that worksheet, try those practice problems. If you have issues with it, come talk to me. We'll get it sorted out next week. And I hope you guys have a great weekend.